Hi everyone, my name is Attila and I'm here to present the final project for Advanced Game Design Workshop in month 9 at Full Sail University Masters of Design. So to start off with an overview, the goal for this assignment was to design and implement a game system using Unreal Engine. And in order to do this, the method was to first draft a technical design specifications sheet, iterate on that on those specifications to adhere to a desired scope and final version to agree upon for the final deliverable, and then to finally develop the game system in an Unreal Engine. So in this presentation, I'll be covering the high concept of the design specification. I'll be breaking down the systems into more detail, and then further going deeper into the data, into the specific data and components that were utilized in the creation of the system. And then I'll end with a demo video, which will be attached to the deliverable on FSO for you. So let's get started. So the high concept, the game system that I chose to create for this assignment is an enemy wave spawning system that has some form of a configuration aspect to it. So it was really important for this system, very key for this system to have a highly flexible wave manager that a designer could just drag and drop in and configure the amount of time between each waves and the specific enemies in to be spawned in the waves, the location of where those spawns are, etc. So I wanted also that the spawners themselves were very versatile, like configurable, like on the fly in the editor, that you could basically select the enemy types that you wanted and what wave number that they belong to, and yeah, that the system would more or less just work on its own. I also wanted to have multiple enemy types to show that this configuration or this flexibility could be accomplished within the time frame. So that was also in the deliverable. Then there were some bonus things that I managed to also accomplish within the time frame, which was player attack and shooting using the third-person template. Remastered, and also getting the enemies to physically die, so ragdoll and die, and then also have a win condition so that you could actually succeed in in destroying all the enemies in the wave and move forward to the next level. So for the system breakdown, we start off with the first enemy type, and the enemy NPC contains a mesh, its own sort of body type in a way, and also has its own movement behavior as well, using the behavior tree. We have two different enemy types in this project, so each enemy type has its own mesh and has its own movement behavior. Then we have the enemy spawner actor blueprint, which is essentially an instance that can be duplicated across the level and contains a drop-down selector for the enemy type 1 and 2. The enemy spawner instances also have a world position, which is a vector, and also a wave ID integer attached to it. So as you spawn all these instances, or as you place all these spawner instances in the level, you'll have the vector location, the world position for each of the spawners where the enemies will appear, and the corresponding wave ID number and that will be utilized later on in the manager. So this is essentially a contained array that the enemy wave manager sees and communicates with. It also has a configurable float, which is time in seconds till the next wave is spawned. And it contains a storage integer of the current enemy ID. So it's tracking the actual wave ID, and that's visible for the designer on runtime to see. There's also a process of incrementing the wave ID every time a wave has spawned. So that system basically keeps going until all the enemies have been spawned or all the waves have been processed through. Also, the wave ID of the enemy spawner and the current wave ID are also communicating in the wave manager. So this is basically a way for to create the desired effect of the proper enemy spawning at the correct moment. In terms of data and components and the elements that were used to comprise the project, definitely using blueprints, which is the node-based code in Unreal Engine, utilizing integers, floats, vectors, and bools to make it all happen in tandem. And also each actor, process, and system component uses its own blueprint. And here's an example on the right side of the I believe that's the wave manager blueprint on the right side. And so but other than that, we're using standard Unreal components and object entity references to make this all happen. So I'll dive deeper into that in the video, but yeah, and then next is the behavior tree. So this is Unreal's standard AI behavior tree for the movement of the NPCs. This is the example of one of the NPC movement behavior. On the right side, the behavior tree for it. We also use AIPerception component for player detection. This was unfortunately not utilized in the project completely, but I would imagine that using the AIPerception, we could also have detection of the player and have some kind of an attack movement to happen or response from NPCs to attack the player. To make it a little bit more exciting as a complete game loop. But yeah. And we're also using the third-person template from the marketplace, which provided the necessary player controller, guns, and the editor to create the level layout. Yep, and so this is the demonstration. I've attached the video to the FSO, but for the sake of time and the actual size of this video, I would refer you kindly to that video to watch more in depth of how this system was created, what are the spawner blueprints look like, how do they work. I also cover the inner workings of the wave manager and each individual NPC behavior in the behavior tree, and etc. So please take a look at that video. But for now, that's the presentation. And yep, thank you very much for your attention. And it was a great class. So take care.